Hello and welcome to Math 1111 video on basic functions and characteristics of functions by Andrea Hendricks. I hope this finds you doing well. We have a lot of objectives to cover, but I would say that most of these are going to be visual exercises, not too much of difficult algebraic skills. We're going to look at some graphs of basic functions, which are the identity function, the squaring function, the cubing function, the square root function, the cube root function, and the absolute value function. These are graphs that you should know really pretty much by heart without having to type into the calculator and get the graphs. And I think you'll get a feeling for that as we go through this. You should also be able to determine if a function is continuous and the intervals of continuity. We should be able to determine intervals where a function is increasing, decreasing, or constant, and determine if a graph is symmetric with respect to the x-axis, y-axis, or origin, and lastly, determine if a function is even or odd. I know it sounds like a lot, but those last two objectives actually are really the same. Even and odd are defined in terms of something that you'll find in objective 4. So let's look at objective 1a, that is to be able to graph the identity function. What is the identity function? It is a function f of x is equal to x. Now remember, what does f of x mean? F of x is y. So this is a function where the input is equal to the output, right? Like if I had a chart and I put in -2, -1, 0, 1, and 2 into this function, what am I going to get out of it? Well, if I put in -2, I'm going to get out of it -2. If I put in -1, I'll get out -1, 0, 1, and 2, respectively. Right, because my function rule is saying that my input is equal to the value of the output. Or vice versa, if you want to say the output is equal to what you input into the function. So whenever we graph that, hopefully you recognize that as one of our linear functions, right? We look at y is equal to mx plus b, and we have the graph of y is equal to 1x, or just y is equal to x. Our slope is the coefficient of x, which is 1. The value of b, which is our constant term, is 0, and that is our intercept, right, our y-intercept. So whenever we graph this function, we get a straight line with a slope of 1 through the origin. Now again, if you had graph paper and pencil, you could see this really precisely. I've done it as good as I can here, but that is the identity function. Okay, so it is a line through the origin with slope 1. What is the domain and range? Those concepts you're not going to really ever get away from. I'll probably ask you that on almost every question that you have on a test. The domain of this function is what do our values of x take on, what can we put in to get something that makes sense, or how does the graph go from the left direction to the right direction, and that is from -infinity to infinity. And the range is our y values, right, from bottom up, and that's from -infinity to infinity as well. The next of our basic functions is the squaring function. I'm going to use FCN to abbreviate function. The squaring function is if I put in a value, my output value is going to be the square of that. So if I put in -2 and square it, I get 4. If I square -1, I get 1. If I square 0, 0, squaring 1, 1, and squaring 2, 4. Now I could use any value of x. I'm just using nice, pretty numbers. And then whenever we graph this, we're going to get -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. This is our basic parabola, a quadratic equation or quadratic function. Quadratic meaning the power of 2. Always has a shape called a parabola. Now what about the domain and range of this? Domain, it extends indefinitely from the left and the right direction. It's negative infinity to infinity. The range is the bottom up. Well, our bottommost value is this 0, 0. So my range goes from 0 and then on up to infinity. You can input all of these on the calculator, and I'll talk about that in the calculator video. Here we're just trying to practice by hand. F of x equals x cubed. We would cube our value of x that we put in. Just be careful for signs. When you cube a negative 2, you get a negative 8. When you cube negative 1, you get negative 1. Cubing 0 gives you 0. Cubing 1 is 1, and 2 cubed is 8. So looking at the graph of this, negative 2, negative 8, negative 1, negative 1, 0, 0, 1, 1, and 2, 8. So this kind of, it looks like a snake, right, as we curve around there. The domain and range of this function are, what do you think? In the left to right direction, it goes on indefinitely, so that would be from negative infinity to infinity. The range, also from bottom up, extends indefinitely from negative infinity to infinity. A few more functions to look at. The square root function. When I input into the square root function, I have to be very careful, right? I cannot take the square root of a negative number, and so I can only start with values of 0 and positive. And I'm going to choose nice, pretty numbers because I know the square roots of 0, 1, 4, and 9. You could certainly put in like 2 and 3 and 5. You would just get an irrational number, and that's fine. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So if I graphed that, again, hopefully you would have graph paper. 0, 0, 1, 1, 4, 2, and 9, 3. Okay. So this one is kind of like a half parabola. And if you look in your textbook, you can see a more official picture of that, or on your calculator. The domain is left to right. Our leftmost point is 0, 0. So it is from 0 to infinity. Now the range is from bottom up. Now the y value at that bottommost point is 0, so it's from 0 to infinity. Believe it or not, this does go on up to infinity. If you put in the square root of 1 billion, you're going to get a really large number. Okay. What about the cube root function? Well, the cube root function is a little bit different than the square root function. I don't have any restrictions on what I can put in because the cube root of a negative is a negative value. Now I'm going to choose numbers that are nice for me to work with by my head because I know the cube root of negative 8 is negative 2. I know the cube root of negative 1 is negative 1. The cube root of 0 is 0. Cube root of 1 is 1. The cube root of 8 is 2. The cube root is actually defined for any number, so you could put that into the calculator if you want to get a decimal value. So whenever you graph this, just put some labeling here. So if I have negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, and then 8, 2. So this graph is going to come through here. Okay. And our last basic function is absolute value. So to graph absolute value by hand, you can put in some negative values, 0 and a positive value, or 2. Absolute value of negative 2 is 2, right? Absolute value just means distance from 0. So all of the absolute values are going to be positive. And whenever we graph that, we would get negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. So this is a V-shaped graph. And the domain is all reals because it goes indefinitely from left to right. What about the range? We read from bottom up. Yeah, that bottommost point is 0, 0, so the y value of that is 0, and it extends indefinitely up to infinity. So absolute value graphs are going to be V-shaped, at least when you have a linear expression inside.